Good morning, everybody. I'm doing a kind of a screencast today because I'm out. I had a slight sore throat on Saturday, so I need to get a COVID test before I return to school. So I'll be heading in after this to get that test. I want to follow up what we did on Friday for my AP class. If you're in my general physics, this will be the first time seeing it. Not a problem. The topic is piecewise linear functions. Uh, and the big idea is this linear function idea. So linear functions just mean that we're looking at something that's going to be y equals mx plus b. As we graph stuff in physics, y is going to be on the x-axis. I'm sorry, y is going to be on the y-axis, x is the x-axis. But rather than think of these as y and x, typically we'll think of x as the independent variable, and typically we'll have a label axis with units, and y is going to be the dependent variable. But for these examples, you'll be given a y and an x. Sometimes they'll have units, sometimes they won't. But this is, again, our topic for the day. So linear equations. And then the piecewise piece just means rather than just having a single linear equation, something like this, you may have something that consists of multiple line segments. So this one would have, here's segment one, here's segment two, and here is segment three. So that's a three piece linear equation. So we'll get to all that as we go through the lesson. So let me get rid of this and we'll move on. Okay, so real quick, if you were in AP Physics on Friday, I made a mistake. That mistake would have been labeled in this group as a sloppy mistake. That I didn't check my answer and I assumed I knew what I was doing. If you're in general physics, just remember that everybody makes mistakes, and don't ever assume because I'm the teacher that I'm not going to make mistakes. Mistakes are never a bad thing, whether they're by the teacher or anybody else. Mistakes are just chances to kind of have a, oh wow, I should be doing, again, the mistake I made was not checking my answer. But again, learning from it as you do this ed puzzle. If you don't do well the first time, you can always email me to reset it. So again, mistakes are totally fine. Everybody makes them. Certainly, I make them. And then the idea is that you fix it so you can redo something, that you figure out what you did, what was the mistake. And you may have to email me, you may have to ask a friend, and then the goal is to kind of learn from it. So that's our whole quick part on mistakes. And I'll get rid of that. All right. So again, we talked about matching linear functions. So I should take a moment. All of you guys, general physics and AP physics, this should be an equation you've seen before, but again, we're going to assume that you're kind of learning it kind of for the first time. So in our notation, we think of y as the dependent variable, and that's going to be on, it's going to be on the y-axis. Dependent vary. If I do a spelling mistake, and x as the independent. And then your slope for us is also called the rate of change. And it's not always, you can always think of it as the change in the y-axis over the change in the x-axis. But a lot of times in physics, it's not going to be, just y over x. It's going to be something like the change in, we might have position, in meters might be the dependent variable, and the independent variable might be the time in seconds. So just be aware that you're not always going to have, for us, that might look like distance over time, or your change in distance over the change in time. But we'll get to all that. But just be aware that in math, they only talk in terms of x and y. You don't typically have units. In physics, we're never graphing y and x, and they always have real things like position, time, force, and mass, and then they also always have units. So be aware that we'll be putting in units. The first half of this lesson uses units, the second half doesn't, but we'll cover that. All right, let me move on from here. All right. So, what is the y-intercept? What is that b piece? And the quick answer is whatever. So here's our time in hours. This is the independent variable for us on this example. Uh, when time equals 0, the number of miles, which we can, the number of miles we could call this d for distance. The distance is 30. So if I was to write this position, this is at 0 hours. We are at 30 miles. And uh, so in our language, this 30 miles is called the y-intercept. And so that's going to come down. This is going to be the b part, which is the y-intercept. This slope of 3 you could work out by doing the slope formula. But again, we would put that the slope is going to be the change in y over the change in x. So we would write this as 3 miles per hour. Uh, and then again, we wouldn't put x, we would put that as t, and this wouldn't be y, this might be our distance. So if we were in physics, we would write this as the distance equals 3 miles per hour times the time, plus you have to add that 30 miles. And so, and then that's going to give you your distance in miles. But just so this is called our slope, and then this is called the y-intercept. So just quick review. And again, it is your math class with a slight twist. So that's our quick one on that. I'll get rid of that. And I should say, don't remind me again if I'm smart. So the next one is again just kind of assuming how do you find the slope? So this is a single linear function. If you have multiple linear pieces, you'll do the same process. We say you're always going to find the change in the y-axis, the change in the dependent variable over the change in the x-axis, which is the independent variable. You can use this slope triangle. So first you have to pick 2 points. So here is the first point. Here is the second point. And you can label this one x1, y1 if you're using your traditional and there's no variables here. So I'll call this x2 and y2. And again, this is really the 2's just designate the second point, the first point. And then you can take those numbers and plug them in here. So this is so y2 is 5. So this will be 5 minus y1, 2, which gives that 3. And again, there's no unit with that one. This is like your math class. And then x2 is 7 minus 3, which is going to give that 4. And again, typically in physics, we'll expect some unit over here, 3 miles over 4 hours. But in this graph, it is unitless. So again, that's your idea. Idea stays the same. Anytime we find slope, we also call this the rate of change. So that's our quick example. I'll get rid of this and I'll pick don't remind me again, so we don't have to keep seeing that. Okay, so easy breezy. So you got your first ed puzzle questions going to come up here once I put that in there. Find the slope from 1 to 3 seconds on the graph below. And then don't forget units. So now we're in, so it's not y and x, it is position versus time. And position versus time. Yeah, we should say the y first, then the x. I think I might have, but we'll do position versus time. And then you're going to find it for this segment right here, which is kind of right there. To do that, super straightforward. You'll want to pick your 2 points and then you'll want to plug into that formula. So I'll pause here. You should get an ed puzzle question and you'll get an answer. Again, if you miss it, no problem. You can come back. You can look at that previous example The change in this is going to be your, your top part. So you'll be taking this one and that one, and then your bottom part is going to be the 3 seconds and the 1 second. So, and again, the units, just make sure we're on the same page. Your units are going to be meters over seconds for this example. And that's what the slope or the rate of change of this graph is going to be. And again, this would have technically 1, 2, 3, 4 rates of change, 4 slopes, because there's 4 line segments. We're only finding the one from 1 to 3. So go ahead and take a moment. You'll find that. And I don't think I need that slide. Okay. So now we're getting to doing this for not a single linear function, but for a graph where you have real data. Again, we're not in math anymore. So we have some data that's going up, some data that's going down. It has time, the unit is in hours, and it has the y-axis is temperature, and the unit is Fahrenheit degrees. So, and the data, again, they're going to use 2 linear functions. One function is going to start at 0 and end at 6, and the second function will start at 6 and go to 12. And again, this function will have a slope uh, and an interval that it's valid from, and the second part of this graph will have a slope and an interval that it's valid from. So we'll kind of walk you through that process. Same math, just kind of doing it twice. And so we'll show that. And so what we're going to do is find the piecewise linear equation for these 2 linear functions. Okay, let's do it. All right, so quick little directions here. How do we do that? So for each line segment, start by finding the slope and by picking 2 points. So again, so here's my first line segment. You can pick lots of different points, but you're better off picking ones that line up with the X and Y axes, if that makes sense. So if you can pick 0, that's a good one. So this is 0 hours, 50 Fahrenheit is this first point. The second point is 5 hours and 58 Fahrenheit. That's going to be this point up here. And again, to find the slope, we're just going to do our normal equation. So the slope is going to be m. It's going to be, I'll call this one, I'll still call it x1, y1, and I'll still call it x2, y2, even though we're in Fahrenheit and that. I'm going to take 58 minus 50 over 5 minus 0. We're going to get a positive slope. It's going to be, and then I can put the units back in. It's 8 degrees Fahrenheit over 5 hours. And that's not a, it's going to be a fraction. So I'll leave it as a fraction, 8 over 5. That is my slope for this first part. And so I found the slope and then solve for the constant b. So the constant b, I think we're going to do that next. So let's take a look at the next slide. Okay, we did all that. And then what is the interval for this line segment? So the interval for the line segment is this first segment starts at 0. It starts at 0, which will be less than or equal to the time, which is going to be less than 6. So we're always going to pick for these linear functions. It includes this lower value and it doesn't include the upper value. The next function will include this upper value. So, and then I switched it to time, which is the actual this, and this is technically 0 hours to 6 hours if I want to be even more precise. So that's the interval. And I know the slope from my last slide is 8 Fahrenheit over 5 hours. And then in my directions, and solve for the constant b. So we need to find the constant b. I think I need to do that. Yeah. So let's do, so what is the constant b? So to find the constant b, and that's not on my directions here. Oh, no, it does say find it using one of your known points. So we're going to plug in y equals mx plus b. And I'm going to pick any point. I'll just pick that. I'll use that point 0, 50, and we'll figure out what that should be. So when x equals 0, y should be 50. So we get 50 equals 8/5 times 0, which is my point, plus b. And you're going to see that for this one, this term cancels out. I get b equals 50, and it's going to be 50 Fahrenheit is my, that's my, this is 0 hours and 50 Fahrenheit. That is the definition of the y-intercept. This is the classic case where it's where the graph starts. So I know my two values, m and b. I know my interval. The last thing is to put all this together and write out my function using uh, this notation. So what that's going to look like for this line segment 1, we get y equals to mx plus b, but we're going to rephrase that using our language here. That I'm going to write this as the temperature equals that 8 Fahrenheit per 5 hours times the time plus 50 degrees Fahrenheit. And this equation is valid from 0 is less than or equal to time is less than 6 hours. So this is kind of the first linear equation for that part. And now we'll do the same thing for that part 2. So take it one step at a time. It's not, it is easy one step at a time, but putting it all together can get a little bit overwhelming. So relax, take a deep breath. Physics always has a very visual interpretation. So, and I tend to do things one step at a time. So now we'll do it for the second part. Same thing, uh, just to reinforce what we did. I'll let you guys do this one. So pick 2 points shown red, and then you guys are supposed to find the slope for this second part. The slope should be, when you do the, you should get a negative value. The reason you get a negative value is it's going to be going down, and your slope should have the units once you're done. Same units we had before of Fahrenheit over hours. We could put the degree sign there or not. And we can just plug in. Again, you could label this one x1, y1, x2, y2. So you'll get a chance to plug in your answer in Edpuzzle here in a second. And then we'll do that same thing is we're going to find B next. So we know M. Well, hopefully you know M. If not, you can try it again. And then, so we did all that. So now what is the interval? Yeah. So the interval, we know the interval is now going to go from 6 is less than or equal to time is less than, well, I don't have another segment, so I can say less than or equal to. This is the second segment, so I can I can let it include that 12. If you didn't, it wouldn't be a big deal. But so on this one, because there's not another segment picking up here, because that segment doesn't exist, I think that's my eraser. Then I can put that equal sign there, but that's a technical part. If you don't have it, it's not a big deal. And then I have my temperature equals whatever you found for your slope times your time in hours. I'm using lowercase t for time, uppercase T for temperature. I think that was, did I do that last time? Yeah. So we didn't talk about that too much, but upper and lowercase are different variables. That can be a little confusing. Plus, now we got to find our y-intercept b. So you know m from the last one. You could pick any point on that you have on the graph. I think I'm going to pick this 9 and 56. So I'm going to use the point when t equals 9 hours. The temperature should be 56. You can plug in the value for your slope, and then that's a known, and then you're going to solve for b. So Hopefully that doesn't seem too confusing. And that's what you'll be plugging into the Edpuzzle. All right. And so that's going to be that. And that'll be the second one. And then the last thing is you'll put all that together and you get your equation for number 2, which we pretty much have written out here once you solve for B. Okay, so that'll be your second part of your Edpuzzle question. And then putting it all together, we're going to have, this is a two-part piecewise linear. So we have one function for 0 is less than t, which is less than 6. That'll be our first function. And then we have from 6 is less than or equal to t is less than or equal to 12. That'll be that second function. One, they're both going to look pretty similar. I'll go back and grab the first function that we did, or we most 8/5 t plus 50. So that's going to look like 8/5. This is Fahrenheit over hours plus 50 Fahrenheit. And then the second one would be the equation you just got a moment ago. It's going to have a negative slope, and then you're going to have your B value right there, but same format. And this is what we call the PLE for that equation. And then, and I'll have to, maybe I should do it, but I think we're good. So you will need to, well, okay, maybe I should maybe do it here to make sure we're all understanding it. So let me take a moment to, let me do that since I haven't done what the issue we had with my AP physics classes. We didn't have the right B for the second part of the equation. So I should do that for you guys here now. So let me do that real quick. So what is the linear equation for part 2? So let's go back here. So let me fill that in. If you didn't get it, we'll get the slope. So we have our two values. So we'll go back and find that. So the slope I have is going to be, this is y2, y1. So we'll get 56 minus 59, which will give a negative 3. And then we'll get 9 minus 6, which is going to give over 3. So this is going to give a fairly straightforward, it's going to be minus 1 degree Fahrenheit per 1 hour, which is, you could just write that as negative 1 Fahrenheit per hour is the slope. So then now we can solve, so that should have been the slope we got earlier. And then now if we plug in negative 1, what does that be? And these are multiplied together. What does that mean B has to equal? And this is what I didn't do for my AP kids on Friday. I just assumed we could pick this 59 degree value and plug it in there, but that's not true because that's not the point we're plugging in. So now we can run this one and we get 56 minus 9, which I better make sure I don't do a math error, which I think is going to give us 47. So for the second part, B is going to be 47. That's Fahrenheit. M is negative 1. And then now I can go back in and do, this is going to be negative 1. And this should have been that 47. And that's the complete answer. So that's kind of giving, and again, check me. We could, and again, I could pick a random point and make sure I'm roughly on target. If I pick a random point at the end, so 12, if I plug in 12, it's going to fall into my second function. So again, what did I fail to do on Friday? I'm going to plug in 12 hours, and I'm expecting something around 53. And so if I plug in 12 hours, I'm in the second function, and I'm freaking out again. So if I plug in 12, I get the temperature equals minus 1 times 12 plus 47, which is going to give 47 minus 12, which is going to give 35. That's not what I'm looking for at all. So what did I do? What did Mr. Fogg do? May have to pause here and So when 9, it's 56. Negative 9, that gives 47. Did I? No, it should be negative. But B, I went the wrong way, right? So what is B? I have to add 9. This is pretty typical Mr. Fogg. So rather than subtract 9, what do I have to do here? I have to add 9. Mr. Fogg, what are we going to do with you? So if I add 9, I don't get 47. What do I get? I get, hopefully I can do this math right. Add 4 plus 5, I get 65. So B shouldn't be 47. B should be 65. To solve this, I have to add 9 on both sides, and I get that 65. That's just Mr. Fogg being his silly self. That means this isn't 47, this is 65. Goodness gracious. Am I going to make the same? Now let me check. Is it important to check your work? If you're Mr. Fogg, it's not only important, it's critical. Now I get 65 minus 12. Let's see if this gives us 65 minus 12 gives what I'm expecting, which is 53. So Mr. Fogg is either the worst teacher or the best teacher, depending on how you look at this. But I make every mistake you guys make, and I have to be super careful. So these are the two correct equations. I still, doing a silly sign error, solved that wrong. But now, because I checked it, I fixed it. And that's always the way. So if there's one thing I can highlight here, guys, make sure you check your work. That this step is ever so important, especially if you're Mr. Fogg. You guys may be better at doing your math in your head. Again, I'm on a video, so I'm kind of focusing on more than one thing. I'm getting text messages too, but that's besides the point. But again, check your work. It should match up. So the last part of this, so again, I wish it was a clean run, but hey, mistakes are what we're teaching here in terms of how do you fix things. And the way you fix it is you always check it. So that's our quick example for that one. You guys are going to now do this. There's no numbers, so all you have to do is just do the math. So there won't be, hours and Fahrenheit, just regular math. Both of these are one scales. The function's super linear, but you're going to go from this graph and you're going to produce the each linear equation. So you're going to have a 4-part linear equation. This will be part 1, part 2, part 3, part 4. It should be fairly straightforward. It won't be quite as tricky as the one we just did together. So for the first one, find the slope of the red segment, and then you'll have a chance to put that in an ed puzzle. And here's a little tip if you need it on how to find that slope. And again, you can think of this one as x1, y1. And this can be x2, y2. And you can go ahead and solve for that. And then you'll find the interval, what values of x is this function true for? And we can use that. The first section we'll use less than or equal to. The second section, because it does have another one, we'll use less than. And then what is a linear equation? You guys can write that out. And it'll pop up in the ed puzzle. And then we'll do the same thing for the blue segment. What is the slope of the blue segment? And you guys have a little bit of help there. And again, we'll use that same less than because it's picking up again. And then you can write the linear equation with the interval for the blue segment. And then we'll go on to the green segment, which is fairly straightforward. What's the slope? And then we'll do, again, this one is going to have less than or equal to for the first one and less than for the second one. And then for the last segment, well, and then you'll do the linear equation with the interval. And then lastly, we'll do the yellow segment. And the yellow segment will be slope will be the regular way. The interval, though, is going to be less than or equal to on both because it ends here. So you can, this function is going to take over on both sides. And then you can write the full linear function for that one. So what I think I'm going to do is have you do this, guys, as a Google Doc today. I'm going to run out of time here. So I'm going to do this as a Google Doc for AP Physics. I'll do it as an ed puzzle for my general physics. But you guys can do this as a Google Doc. Answer wherever I asked you a question. If you guys could put the answer in a Google Doc, that'll get you guys started doing this assignment. My general physics can get the ed puzzle. I might give it to you guys, but this is to make up for that mistake I made. Get this done today, and then I'll be back tomorrow. I think I should have I'll go in and take my COVID test today, and hopefully it'll finish up today and I can be back tomorrow. So hopefully this makes sense. I'm going to post this video, and then I'll post a Google Doc and you guys can answer those questions. So you won't get an ed puzzle. You guys are just going to get a Google Doc, but my physics will do the ed puzzle rather than just the Google Doc. All right, you guys, I'm out of here.